Hi, this is Laura Stevens and Sarah from the Walt, here to talk to you about how we can learn from nature's functions and strategies to help solve our human design challenges. As a biomimic, you can recognize biological functions and strategies, let's say to help us solve environmental issues, like storm flooding or air pollution. Well, if we were to learn from nature, how would nature solve these? With all her 3.8 billion years of experience, what would she advise us? Because biomimicry looks to learn from nature by translating the biological functions and strategies into human design concepts, let's start there. How? Well, we first look at what your challenge is. What would you like your solution to do? If we take heat, for example, what would we need to do to survive extreme heat? Well, we could cool off, or sweat, or ventilate, or get some shade, or protect from extreme temperatures. So what would the function be that's needed to help solve these challenges? Well, if we look at the function, protect from temperatures, we need to look at the organisms that do that, the organisms on the earth. So, how can we ask nature to find the answers to these questions? When we ask nature how she would protect from temperature, we go to the website asknature.org, look at the biological strategies, protect from physical harm, protect from non-living threats, and protect from temperature. Now, the reason why we use these verbs, protect from temperature, is that you can find these in the biomimicry taxonomy. And this, if you follow these verbs, these functions, then you can ask nature how nature does or how nature solves these problems, these challenges. For today's exercise, we chose 5 organisms to help us find out: the West African elephant, the prairie dog, cactus, the penguin, and the wasp.
For each of these biological organisms, we will make a statement and ask you if this is true or false. Please pause the video and answer the poll in the top right-hand corner before restarting the video.
The West African elephant is our first champion today of the function protect from temperature. As we know, the elephant must live under the hot sun. Well, it has these random patches we call thermal windows of blood vessels that are concentrated. And the higher the concentration of these blood vessels, the easier it is for them to give off heat. So the function, we call it protect from temperature. And the strategy, this is your true or false question, would the strategy be random patches over the elephant's skin act as a thermal window where higher concentrations of blood vessels let more heat escape? True or false? This answer is true. The strategy the elephant uses to protect himself from temperature is that he has thermal windows of concentrated blood vessels on his outer skin, and the more concentrated these blood vessels are, the easier it is for heat to escape. So the answer was true. Well done.
If you were to get into the science, you would find how the elephant actually carries out the strategy, how big and how many blood vessels are in these patches, and exactly how the blood streams through them to dissipate the heat. When you discover exactly how the strategy works, this is called the mechanism. We will look at these mechanisms in future lessons. For now, let's continue with the true and false.
Our next organism is the prairie dog. Prairie dogs have one opening in their burrow that's higher than the other. Downwind, there's a lower air velocity, so a higher pressure. This creates a vacuum-like effect, and the air gets sucked in through the mound, cooling the interior. This is basically the Bernoulli's principle in action. Because prairie dogs have a different strategy than West African elephants for protecting themselves from heat, our question for you today is, does the black-tailed prairie dog achieve the function of protect from temperature through using the strategy of regulating air and distributing gases? True or false?
The correct answer is true. The prairie dog is also a champion of surviving extreme heat in the desert. But do they do it like the African bush elephant? No. They have their own strategy to protect from heat, and they do this by regulating air and distributing gases.
Ribs all around the cactus where the sun will be shaded and non-shaded areas. So the shaded areas will be cooler. The air around them will be cooler, thus cooling the cactus. So my question is, does the barrel cactus protect from temperatures by the strategy radial ribs creating alternating shade and non-shaded sides, slightly cooling the air? True or false?
The correct answer is true. Not only does the shade help the plant avoid evapotranspiration, but the shaded and non-shaded areas create little pockets of warmer and cooler air. The ribs of the cacti create a neighboring area of shade, which means slightly cooler air temperatures in that zone.
Wasps have an interesting strategy to protect themselves from temperature. They can protect themselves from both cold and the heat. They have an extra layer, they build an extra layer of comb around their hive. This gives them a buffer space to protect them from the temperature that is outside and keep their temperature more constant within the hive. So the question is, does the wasp achieve the function protect from temperature using the strategy build an extra layer of comb to buffer the outside temperature? True or false?
The correct answer is true. Wasps build an extra layer of outer empty combs to protect from both cold and heat. The outer layer of combs rarely have a few broods present.
When looking for strategies to protect yourself from extreme heat, you could also look for strategies to protect yourself from extreme cold temperatures. The penguin has a great strategy for that. With the blood going in and out of the wings, the warm blood within the body will warm the cool blood coming back from the wings, thus preventing heat loss. So our question for you today is, does the penguin achieve the function protect from temperature by using the strategy countercurrent heat exchange via the vascular design prevents heat loss? True or false?
The answer is true. Wings of penguins reduce heat loss by forming a countercurrent heat exchange via their vascular design. Blood is supplied to the wing at a core body temperature, and outgoing arterial blood heats the cooler incoming blood close to the body. Heat is thus conserved and returned to the body core instead of traveling further along the wing to become lost to cold water.
Thanks for joining us, and feel free to contact us on our LinkedIn pages. This is Laura Stevens signing off from the Netherlands.
And Sarah van der Walt signing off from South Africa.